Welcome to Emerald Hill Skies. We're here again tonight. We just went the night before last, but we're back with a beautifully clear night tonight. And we're glad you're here with us. We've already got several on the live stream. Looks like Tiffany's already shown up. Good evening, Tiffany. And Dennis is there already. Good to have you aboard, Dennis. And also Ken. Welcome to others. If you haven't told us where you're logging on from, we'd invite you to do that so that you can get started with us here. This is like team astronomy. And as we have been for some time, we're working our way through Phil Harrington's book, Cosmic Challenge. I think we're down to the last 188 objects that we still need to observe. We're located on the outskirts of Louisville, Kentucky, and we have a Pier-Tech Tele-Station 2 observatory with a RASA 11, that's a Roe Ackerman Schmidt astrograph telescope, on top of a Pier-Tech Adjustable-Height pier, and we're using as our main camera the ZWO ASI2600MC Pro, and we're using as a sky cam the ZWO 183 camera. That sky cam picture I love because it gives, 178. That sky cam picture I love because it gives us kind of a better connection to the sky. Kind of keeps us connected even though we're about 200 feet inside in a air-conditioned office building, and the observatory's out there in the side yard across a service road about 200 feet away. The signal being carried in from a fiber optic relay setup over fiber optic cable. We're able to use that ZWO ASI 178 camera to good use so that we can keep a good connection with the sky. And it's on top of this RASA 11, as you can see, and it uses the same kind of rig to be able to, at the base of that, we've got this little rack down there, and converts everything in that little box that you see with the two green lights on top, converts it all to a signal that we can beam inside the building here and be able to bring to you. So there's our sky tonight. It's pretty clear. We're glad to be looking at a compact galaxy group called the Hickson Compact Galaxy Group 50. And the way Phil Harrington's book is set up, the objects are numbered, and this one's object number 160. And then we use a planning software, it's called Astro Planner, to be able to list all those in a custom list that we put together in Astro Planner. And you can see right up there at the top, we're on this first object, HCG50. And look, right there before your very eyes, I don't know if you can see that or not. Let me switch over to the screen view. We have a bit of a glitch in our Astro Planning software. You know, we've been encountering this glitch, and I don't know exactly why, but I dutifully send in the, whenever it lets me, I send in the report. This time it's not even going to let me send in the report, so that the programmer, and Paul is very active on the forums, so I'm going to have to tell him about this. I send in the report so he can see that in this particular version of Astro Planner, we're encountering this glitch. And what I do usually is open up the program a couple of times, and that enables us to, eventually it starts and works. I tell you, in spite of that glitch, I still believe beyond the shadow of a doubt that it's the best targeting software because it's so flexible. It lets you put together observing plans that you can edit truly in every way, sometimes even beyond our own good. And I'm just going to drag it over here to the side where it was. We're going to try to bring it back up, open recent Cosmic Challenge, and hope that it doesn't glitch this time. Okay, we don't really need 2 copies of it open. So let's close this one. You know, I often hear people say about electronically assisted astronomy, they'll say things like, what could possibly go wrong? Because we're running about, I don't know, 3 or 4 core things, and then when we're live streaming it, we're running another 7 or so peripheral things, and all of these add up together to make a rather complex show, you could say. And it is live TV, so to speak, you know what I mean? So you're seeing the real thing that I'm seeing just as I see it. Okay, this time instead of closing Astro Planner, we'll move the observing list over to the right on top of the first copy that we opened up. And I hope that this time it doesn't clash in any way. On the live stream over here, we can see that Tiffany's welcoming everybody into the room. Dave, good to have you aboard. It looks like you've got an all-sky camera too, lives out in the garden. Larry's greeted everybody. Dave says there's some reports of northern lights last week in Nebraska. That's really low for northern lights, isn't it? But as you guys know, this has been a year for I wonder if I turned off the highlighting, if that's one less thing that Astro Planner would have to worry about. And let's hope that, okay, so we're back at HCG50 over there. And we've already plate solved this image, so the HCG50, the Hickson Compact Galaxy Group 50, should be here in the middle, but as you can see, it's not visible yet. We have about 28 frames, 9 minutes. So let's zoom in here, see what we've got. In terms of our deep sky image annotation, the Hickson group is not going to be listed in Robin's default list. So what we're going to do is use Pete's little control panel that he programmed for us. He calls it EAACP, and we're going to copy the data, and then we're going to paste it into, right there's where this compact galaxy group should be. So that places a crosshair exactly where we should be able to see this group. As you can see, it's not there yet. So that means a couple things could be happening. One of them could be that we don't have the coordinates correct. So let's check that first, just to make sure we've got the coordinates correct. And I guess the best place to get those coordinates, let's just go out to the web. So we're going to toggle over to, there's our friend, the Hubble Space Telescope. We're going to say HCG50 Wiki. And that didn't bring it up. So let's spell it out. Hickson Compact Galaxy Group 50. There we go. Get the Wikipedia page. And so let's let's look at the coordinates we have here. It says that it should be 00 hours, and right away that's a mistake because it says down there 11 hours. So it does look like there's a mistake. Okay, I apologize for that. Let's stop the live stacking. And let's edit the coordinates. And what it should be is 00, 26 minutes, 26.0. So we'll put, I guess, 0 for the arc seconds. And then for the declination, it should be plus 25 degrees, 43 minutes even. And then we'll save those. Now with that saved, let's connect to the telescope and slew to the new location. So you can see a bit of an adjustment there. Where do those other coordinates come from? I don't know. Okay, so you're seeing a live shot of the RASA traveling to the new location, and it should be an altitude of 11 degrees, so fairly low in the east. I hope we have a good clean line of sight. Depends on that tree, doesn't it? We could be into that tree. So let's go back to our screen now. I see some stars there. And we did get a good plate solve. Yeah. Does look like there were a few stars in the frame, but not too many. So we might be into that tree. We might have to come back to this target in a few minutes. Looks like it is rising. So we could always come back to this target in a few minutes. Red Angel, good to have you back. Oh, there are a few stars there. That's good. Okay, so let's turn off deep sky image annotation and solve again, just to solve. Then let's turn deep sky image annotation back on, and let's grab the new coordinates.
DSA completed.
Paste those into SharpCap. That should be the location of the galaxy group, we hope. So now we'll tune up our live stacking histogram here. Looks like we're getting a partial tree there, sadly. Yeah, so what we're doing, what you see in the image here is we're seeing just the edge of that tree. So we're going to have to wait until it rises up to here. So that's 12 degrees altitude. So we'll just come back to this. While we're on this, though, let's go back to our web page and finish this. So let's stop the live stacking. Let's go back to the web page and finish this. 17. 21, no, 06, 06 plus 54, 55.1. So that's a 1/10 of an arc minute, which would be 6 seconds. Okay. What do we have here? Wonder why that's solid white. What are you guys making of that? Why is that solid white? We must be looking... Is it because we're looking into the light pollution of Louisville, you think? Well, let's switch targets anyway. Surely we don't have... That does look like a pretty mean skyline of light pollution, doesn't it? But still... Eleven 17.6. 17.6. Can't figure out. Let's go ahead and let this shoot us a new image. Hickson Compact Galaxy Group 50. Observing compact galaxy groups from Paul Hickson's 1982 study is an interesting challenge for owners of the largest background telescopes. Most are at the edge of detection even from dark sites, so offer great tests of our observing skills as well as the quality of our instruments' optics. Well, that's definitely what we're seeing tonight, isn't it? Let's tune up our live histogram here. And try one more time to paste in the custom info.
DSA completed.
Okay, so let's try this again. Let's so we're looking up there. Boy, it is at the limits of our observing tonight, isn't it? I'm not too sure whether or not it's because we are so here's what we're seeing. Nothing too zany there. Maybe it's just got to yeah, there's that triangle. That triangle. It could be that it's just going to take us a while to be able to bring this image in, huh? By the way, did you guys notice I have on my NASA shirt tonight? So what this might also do is tell us that maybe it's good to pick an easier target for the first target, so we make sure that we are, you know, in the zone, so to speak. Boy, it's a dark night out there. There are no clouds in the sky, so we're not going to be able to blame it on that. There's our sky. Plenty clear. We're at 130% here. 12 frames, just 4 minutes of integration, so I guess it's always possible, isn't it, that this being a very faint object, I'm looking at the sketch that he gave us. I'll show you what I mean. This is a little chart that Phil Harrington gives us to try to find the object. So here is a bit of a odd-shaped house. It's a contemporary design house. Here's the bottom of the house. There's a wall, and the roof goes straight up on that side, and then it comes over. Now, with that in mind, to find HCG50, we go up the opposite side of the house from the high roof, and we go up about a little more than double the size of the roof. So you see, I'm imagining it as a house like this, and I'm saying it's a contemporary design house, but we take the side that doesn't have the high roof and we go a little more than double. Okay, so let's keep that in mind now. So now look at our picture. Here is the house. And we're going to go up a little more than half. And there is the star that is pictured right above the words here. HCG50, there's a star pinpoint right there. Going a little bit farther and a little towards the center of the house, we're supposed to find this group. So back to the screen. So now let's put our deep sky image annotation back on. That's a pretty good approximation of where this galaxy group should be according to his chart, isn't it? A little higher than that star. It should be right in here somewhere. So let's zoom in on that area now. We're at 347%. Still seeing nothing in 7 minutes. But you do notice that our focus is not perfect. So I tell you what, let's do. Let's stop live stacking, but let's just stay where we are. Let's just go like that. Just turn off live stacking there. Let's turn off the camera. Drop out the Nina. I focused before the live stream started, but I suppose it's possible that it's been about what, an hour since I focused. I guess it's possible that the focus has dropped out that quickly. So let's do a focusing run here. Tiffany says, cool shirt, Doug. Yeah, I figure if they see this, then Tiffany, they're going to want to hire me, don't you think? And yes, it's tiny and faint. So let's read a little bit more while it's focusing, and you'll be able to see the focus routine running here. Let's make it a little bit bigger. So remember, I know that you guys who are the usual suspects, you know how this automatic focusing works. But for those who might be just visiting the channel for the first time, this is an automated routine inside the astrophotography program called Nina. And it automatically shoots 2 camera shots at each position of our electronic motorized focusing motor. And it takes a picture where the camera is currently located in the focusing train, and it memorizes where that focus was captured, where that picture was captured, at which focus position, and then it moves slightly. It takes another picture, takes 2 more in fact, moves slightly, takes 2 more, moves slightly, takes 2 more. You can see the first couple of moves here is kind of wacky. Oh, there are not enough focus points. So that's interesting, isn't it? Okay, so there. We just captured two more images. Two more images. And what it's doing is it's calculating the half flux radius, is that what it's called? That, in other words, it's calculating the luminosity of each star. And then it moves a little bit and captures the luminosity again and tries to calculate if it's seeing any improvement. And it's definitely wacko. Then what it does is it tries to establish a predictable parabola. And using that parabola, it's going to try to calculate good focus. But look how it's moving back and forth. And what we should see is a trend line that's a gentle curve, and when it moves in one direction, it should be more and more out of focus. That's not what's happening. Okay, so let's stop that, and let's go back and look at the sky view again. Maybe it's just too much down in the horizon. So, tell you what let's do. Let's go back to the North Pole again. So that we're kind of away from those horizon lights, you think? And let's capture a good benchmark of focus again. So now what the scope is doing is swiveling back around to North Pole, and there it is, pointed north. So the security camera that we have out in the observatory kind of looking over its shoulder as it points north. So now with this pointed north, let's do an autofocus run here at a little bit darker patch of the sky. And let's see if our focus run is better here. In the meantime, Tiffany, we have to ask you, what's the latest on the gas leak at your house? Were you able to get a good contractor in there at a reasonable price and locate that leak and maybe patch it and test it so you can have a stove and working hot water again? I don't want to speak too soon, but already you can see that this is a much more predictable parabola now. Yes. So that's what was going on. We were too low in the lights of the horizon, and that might also be fouling up our view of the Hickson group. So I tell you what let's do. Let's find a more interesting startup . boy, is it... Let's do a search again. I mean a sort. It's a nice looking parabola, isn't it? This is the way it should look. See how down here at the base, the star, what this tells us, this is the luminosity here in the left axis, the y-axis. It's the luminosity of each star. And it's looking at, you know, likely it's looking at 50 stars or 100 stars and averaging them. And look at how it's calculated the average half flux, I think that stands for HFR, the half flux radius. It's calculated that they're much smaller pinpoints here. So now it's automatically set our focuser here for the best focus that it can make. So now let's go back and disconnect the focuser and disconnect the camera from Nina. These programs are kind of stingy with the camera. And then we'll go back to SharpCap and reconnect the camera. And much tighter focus there. Now, I'm wondering, are those all of the targets that are left that we've not observed? No, so look at all these. So when we sort this list, it should put all those at the top of the list. I'm just going to pick out a target here that's a little easier for us to see as our first target, just so we can get some. Let me go ahead and turn the highlighting back on for the ones that highlighted are for the not observed. And this will let us find a target that's a little easier. What about the something like those are dark nebula. NGC7537 is a galaxy. Let's go there. NGC7537, and that's object number 108. Let's start with something a little less elusive, just to make sure all of our equipment's working well. So you can already see that that's pointing a little more easterly. And this object is NGC7537. And while that's plate solving and tuning in, let's synchronize stellarium to that and go over and look at this object in Stellarium. So you can see we're almost right over due east. It's a little bit south of east. And so that's interesting, isn't it? NGC 7537 is here and NGC 7541 is there. Are those trails of stars for real? Are we really going to see those in our field of view? Surely not. But either way, we're over the top of just a little bit south of due east. It's going to be an interesting target, isn't it, if it really looks like that? Surely it doesn't look like that. Let's go over to the live view in any event. Oh, I know, we didn't tell our scope to start tracking. That's what the problem is. So let's oh yeah, tracking is enabled. Do you think these galaxies actually look like they do here in Stellarium? Why would they look like that? That almost looks like an image of Jupiter with all of its moons, right? Stellarium, why would you have that? Very interesting, isn't it? Oh, thanks. Thanks, Dennis. So this is the view in Stellarium of NGC 7537 and NGC 7541. This is the built-in artwork in our planetarium software that a person is supposed to be able to see when you zoom in on these two galaxies. But why do these two galaxies have those strange alignment of trail of stars? So now we're going to go back to our live view and going to do real live observation and try to get to the bottom of this. Pretty ugly there so far, isn't it? But there you can see our two galaxies at least. Now why it's so ugly must have to do with the digital histogram was turned on and was not stretched properly. Why that got turned on, I don't know, but that appears to have fixed the majority of our problems. So I don't know how a person would have known if they didn't have some observing experience to go up and check that digital histogram up there on the right-hand side. I can only say that that's what occurred to me to do, and sure enough, the digital histogram was turned on and was fighting against us. So we had to turn it off altogether. I did an auto stretch first. But anyway, here are these two galaxies. Now, as far as what Stellarium was seeing, there is a line of stars here. And I guess there is a line of stars here. But these two galaxies are right here. Now that's 150% of our camera's ability. So in other words, we're relying a little bit on the digital zoom here beyond the optical capabilities of our camera. What that means is these galaxies are faint, but they're also very tiny. And that's just part of it using a RASA, which has a very wide field of view. The RASA's field of view is 2 degrees and 10 minutes wide. It's very, very wide field of view for a telescope. 1 degree, 27. So over 2 degrees wide and 1.5 degrees high. So yes, tiny objects are going to be tiny, but these are very tiny, even without the RASA's perspective. So we're finally seeing an object here, and I apologize that it has taken us some time to get to this, but that first Hickson group, we were just not seeing it, were we? Naughty histogram. Yeah, that's right, Tiffany. So let's read what Harrington says about these. He says, they're visually interesting, but they hide among faint stars. They're only 3 arc minutes apart, edge-on spirals, but he feels like they create an attractive pair of faint fuzzies that float in a field of dim stars. And he says, if you've got high light pollution, it's going to make them harder. And we do, but we're using Celestron's light pollution filter that's custom made for the 11-inch RASA. Tells you how to find it, and then he says that NGC7541 is the larger of the two. Long, very thin spike of light. 12.5 magnitude. There have been supernovae that have been spotted in these. And 7537 is the dim one over to the right. It's smaller and fainter. And through his 8-inch, in normal conditions, he can't see it. He has to be out in absolute stellar conditions, and even then it's just an oval glow. So I think our EAA techniques are working well for us. We're seeing both of these galaxies about as well as we could expect to see them. But you can see how they are a challenge, and that's what his book is all about. Cosmic challenges. So we're going to go over here. These two are associated in our list. So we're going to say, using our EACP control panel, we're going to say NGC7541 does indeed look like a fleck of light, maybe almost comet-like, growing a little wider toward the, I think that's, in our view, I think the west might be up. NGC7541, 7537. 7537 is fainter and much smaller. But both objects were obvious after just 20 seconds. Okay, so it creates an observation.
Observations for 2 objects logged.
For both objects. Dennis says these are 120 million light years away. Tiffany says, wow, no wonder they're tiny. All right, so let's go to the next object. Now let's go back to a little more challenging object again. Why don't we go back to that Hickson Galaxy group and give that another try. So you can see the scope moving back toward that Hickson Galaxy group. Slowly making its way over toward that part of the sky. If you were with us night before last in our stream, we worked on a very challenging object that was behind a galaxy. It was a quasar. And it was a very interesting chase, and I'd encourage you to go watch that live stream. It would be the next to most recent. This is back now to HCG50. I'm already liking this view a lot better. This is what it should be looking like in that part of the sky. And the software found a set of stars that matched its database for where we should be pointing in that part of the sky, and now it's tuned us in so we can be spot on to this particular target. Okay, we're going to okay, so there's our little house again. These must be trees here. We're at 20 degrees altitude. Now we might be seeing some objects now. Now I think our
DSA completed.
there's that. And let's one more time.
DSA completed.
And then there we go. So that should be the exact location of one of these faint galaxies that we're looking for. It's possible that we're just going to have to, there's the top of that house that we talked about. Yeah, I'll tell you what, the way the diagram works, let's look at this again. Look how there's a tiny little star out here, and then there's that tiny little star there, and look how at the middle of that right angle is where we should find this array of tiny little objects. So that is the star out to the right, and that is the star below. So right here is exactly the place that we should find our Hickson compact galaxy group. So let's remove that crosshair and let's zoom in a little more. Let's darken the sky just a shade more, get rid of some of that. Now we're starting to see some material here, see? Now when we had the sky with all that confetti noise in it, it was hard to see this material because the noise hides it. And that noise will keep disappearing. We only have 4 minutes of integration, so 4-minute time exposure. But just, if you've been on the channel for a while, and if you really have your eyes down close to the screen and your screen brightness is turned up as bright as you can get it, I'm going to hold the Shift key down and use this bar for the black level. See how right there we're starting to get some grain. But if we move it a notch or two to the right, we can begin getting rid of that grain. And now look, you can still see some material there. Now let's bump up the mids and see how it makes that material brighter. Of course, when it does, so far it makes the grain brighter, but that'll continue to get better as we gather more and more subframes. We have 18 subframes that are stacked together inside the software's brain, making a total integration of 6 minutes. But this is going to take, probably a total of 15 minutes. But this collection of material here is going to be our objects. Isn't that wild? It's the way EAA works. We're starting to see a hint of something here. So let's read about it. Look how we're starting to see a bigger hint of that. Observing compact galaxy groups from Paul Hickson's 1982 study is an interesting challenge for owners of the largest backyard telescopes. Most are at the edge of detection, even from dark sites, and so offer great tests of our observing skills as well as the quality of our instruments' optics. I'm looking over here, and a few more folks have shown up. Ray is here. Welcome, Ray. You were enjoying dinner with your wife for the anniversary. Tiffany wishes you a happy anniversary. There's Jack Henry DG. Tiffany, welcome. Jack. Ray says 35 years and going strong. That is quite a feat. Ray, good job. Tiffany, have you told us yet what happened about the gas leak? Larry, 54 years next week. Congratulations on that. Tariq Al-Khamrani. Tariq Al-Khamrani. Good to have you aboard too. You might tell us where you're observing from, Tariq. Anyway, Harrington writes, I especially enjoy the hunt for number 50 in his list of 100. HCG50 is comprised of 5 dismally faint galaxies, crammed into an incredibly tight 42 arc seconds. Why is this my favorite Hickson challenge? Largely for the company it keeps. HCG50 is just 1/3 of a degree from the famous Owl Nebula, which is fascinating in its own right through large apertures. So let's back off for a second. And right here should be the Owl Nebula. Yeah, it's a ghostly glow there, huh? It's kind of getting a little bit lost in the horizon lights. So that could affect our ability to see the Hickson group as well. I don't think we're down in the trees yet, although this line here and this line, these could be the beginning of trees. Oh, there you can see the Owl Nebula a little clearer. So he's talking about for the company keeps, yeah, look, trees are sneaking in here. Bummer. So we'll find our house. Is it right there where they are? Right down here. Oh yeah, here's our triangle. The Hickson Galaxy group makes a triangle there. So it's dark in the sky. Too much. There we go. You see how they snuck in there? So we're darkening the sky. Wow, it's tough in that. Take a look at that light glow. We're aiming right at it. That's the Louisville's light pollution dome. It's making it pretty challenging for us, isn't it? But you can definitely see this one now after 12 minutes. Let's look at what shape they should have. There should be 2 on the side of this star, and then 3 on the side away from that star. And the 3, A, B, and E, should look like Mickey Mouse ears. So let's look at the magnitude of these. Oh my goodness, they're 18.7, 18.9, 19.6, and magnitude 20. So A is apparently the one we're seeing here at magnitude 18.7. So what we're going to do here is we're going to say at 14 minutes, we could see the beginnings of HCG50A magnitude 18.7. We felt like the RASA with EAA was indeed going to be able to pull these in, but we might have to come back to them on a night that they are not positioned just 20 degrees above the light dome struck horizon of Louisville.
Observations for 6 objects log.
Okay, so I don't really count this as a great observation, but I do count it as we're starting to see them. And then let's come back to this object when it's higher in the sky and away from the light dome. How about that? I'm not admitting defeat. We're only at 15 minutes integration, but I also don't know that it's the best night at 18 degrees above the horizon. I don't know if it's the best night to fight the Louisville Light Dome, especially if these represent some of the trees in that light dome. So let's go back. So let's say, for instance, I don't know, just for the sake of supposition, let's say that, see, I don't think they're down this low. but they're definitely down this low. What are those 3 stars there? Let's go back over to Stellarium. East. I don't think that's the object we're looking at. Let's go back over here. We can just search. No, there we go. HCG50A. Here we go. That can't be right. HCG50. Here we go. A. Stellarium
Selected.
Seek. All right. So, yeah, those 3 stars are the Dipper. The handle of the Dipper. So we're looking down below the bowl of the Dipper. Now let's go back to the SkyCam. Oh wait, let me show you what I'm looking at here. These 3 stars are of the handle, and the Hickson group is below the bowl. Now let's go back to the SkyCam. Here are the 3 stars of the handle, and that's the bowl. So we're losing the group in that sky glow, sadly. So we're going to have to come back to those on a night when it's not quite so deep in the glow, huh? Okay, catching up here on the live stream chat. Wendy, welcome. Good to have you aboard. Tariq, did you ever tell us where you're viewing from? You know, Tiffany, I was thinking the same thing. I thought we had an easier time viewing it as well. I think it was higher in the sky. So that's what we've learned here tonight, is not to battle that light pollution quite this much. Okay, so having said that, let's go back to the live view. Yeah, these could be trees that are interfering as well. And let's zoom in one more time. Too many trees. Too much sky glow. But doesn't it show you how EAA and the scope can dig? This is a magnitude 18 object here that we're starting to see the the beginnings of. We're looking through trees, and we're looking into the light dome of Louisville, and look how we're starting to bring out that magnitude 18 object here. 21 minutes of integration. It's fascinating. I don't see how electronically assisted astronomy can do this. See how we're starting to pick up the other objects here now. Again, I think it's just partly the experience of knowing what those things begin to look like. But objects here and here. So we know something is there. Let's come back to this again on a night when it's in a darker spot of the patch of the sky, though. But I'm thrilled that we can pick up a magnitude 20. Well, these are actually on this side, magnitude 19.5. We can pick up a magnitude 19.5 glimmer, hint, in that light pollution. I think that at least gets us started. All right, so let's go back to our astro planner and do another sort. -2728, 1413, -3, -21, -46. Wow. These other objects that we haven't observed are all below the horizon. Okay, so this is what we have to work with. Let's go to it. Object 178 is at 27 degrees. It's as good as it's going to get. So that is, wow, that is Messier 31, and what we're looking at in Messier 31 are the globular clusters. Books, it's good to have you back. Oh, Tariq Al-Khamrani from UAE, from Dubai, in other words, right? "7:50 a.m. there in Dubai. Are you in Dubai, like the city of Dubai, or out in an outlying, darker part of Dubai? Maybe Are you from up there in the Align part? The Align part of near Align, or are you from down closer to the Dubai part? How interesting. Oh, you're not living in Dubai right now. So where do we catch you today? You're in Ahman City. So that's another city in, wow, Bordel 89. AJMAN. So that wouldn't be pronounced Ahman. That would be maybe Ayman City. Okay, we've already started live stacking this, so I'm going to do a quick little detour. Go over to here and bring up AJMAN City. I see. Sharjah. So basically it's near Sharjah. So here's Dubai, you know, the city of Dubai. And there's Sharjah. And here's this Ayman. So this is a very urban area you're in. No wonder it's Bordel 89. Wow. So what we're not going to do is we're not going to complain about our light pollution. Because wherever we are, we probably don't have it as bad as Tariq Al-Hamrani. Yes. So what they've done is created waterways in here to get you making more port space, huh? For boats to come in there. Look, there's a camel race course. So, Tariq, have you been to this Al-Tala camel race course before? I have never been to a camel race. Boy, I tell you what, I would love to visit, however that's pronounced. AJMAN. So what we're going to do now is say pronunciation of AJMAN Ahman. Ajman. Ajmanna. 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 Okay. Tariq is from Ajmanna. He does not go to camel races at all. But he does pass by that camel raceway. And you're going to survive with Astro regarding to conditions. All right. Tiffany says, tough viewing at your location. You're right, Larry. Kentucky's famous for horse racing. Now, lest you think we're on a detour here. Yes, we are on a detour, but we wanted to pronounce Dyke's city correctly, Ajmana. But what has been happening is this area has been collecting data the whole time we've been talking about UAE, the United Arab Emirates. So what we're looking at, we're looking for Messier 31. Let's do our sort here, our adjusting. So my question is, this really M31? No. And why didn't we see M31? So it could be that these coordinates are not correct. Well, bummer. Let's go to M31. Now we're talking. Ajman. There's not a little kick on the end of Ajmanna. Okay, Ajman. We just wanted to pronounce your city correctly, buddy. Okay, now we're talking. I'm not sure why those coordinates weren't correct, but we're going to have to compensate for those. Okay, so now in M31, we're going to try to find several globulars. And these are going to be challenging. But the whole thing is challenging, right? Okay. Now let's see how this works. Let's try using our plate solving trick that Pete gave us.
DSA completed.
So this should be a globular named G351. And let's put it in. Didn't show up there. Let's try G272.
DSA completed.
That one did. Okay, so the first globular we're going to look for here is right here. And I bet that's it right there. So the reason why this is so faint compared to most of the globulars we're looking at is because when we observe globulars normally, they're globular clusters in the Milky Way. What's interesting about this globular, which is called G272, the one that my little mouse pointer is pointing at right here, what makes that globular unique is it's not even in the Milky Way galaxy. That's a globular cluster in the Andromeda Galaxy. So if we back all the way off, you'll see that we're actually looking at the Andromeda Galaxy. And we're looking at one particular globular cluster in the Andromeda Galaxy. So what if it's possible that there's some, I don't know, planet in one of these trillions of stars in the Andromeda Galaxy that has some kind of intelligent life on it, and they have big telescopes? What if right now they are looking at the globular clusters in our galaxy, the Milky Way galaxy? I don't know. It's fun to speculate on, isn't it? Either way, we just found this. So I'm just going to say this was like a fuzzy globular. Now let's try G351 again. Because a while ago, it was as if it was completely out of frame. Which is possible, isn't it? Right now, Astro Planner is...
Observations for 29 objects logged.
Oh my goodness, it logged all of them at once because I forgot to uncheck that box. Let's grab what we think are
DSA
these.
completed.
Yeah, that's off frame. Okay, so let's go with G318.
DSA completed.
Okay, so here's supposed to be G318. Now, let's do this. Let's go up here and say solve only again. And take this off and then put it back. Okay, it's still telling us to go there. So let's see what we've got down here. Ah, look, there is a very faint fuzzy right there. Okay, so there is that G318. Man, it's so faint. Without deep sky image annotation, how would we ever find that? I tell you what he gives us in he gives us a drawing of the Andromeda Galaxy, and he we're supposed to use this chart to find them all. But man, it's like a needle in a haystack, wouldn't it? It would be like looking at a needle in a haystack. Let's look for this one that we're on right now. G318. First, you've got to find the number on his drawing. And that's hard enough. Okay, I found the number. Now you've got to try to compare it and do human plate solving. And then once you've found it, the thing that he's pointing to is just a fleck. But sure enough, let's just do this for the sake of, so we can see that the deep sky image annotation trick really works. Let's back off a little bit here just so we can get the start of our shape. Man. This would be so hard to do all these. I'm looking for a way to make sense out of this. Okay, I just figured out a way we can make sense out of it. Okay. In this drawing, so we're down for orientation. We're way out in the outskirts, in the suburbs of the Andromeda Galaxy, down here. And that represents, in his drawing, can you see G318 there? Now look how below where his little cursor is pointing, right here, right there, is the peak of a house that's made up of that star and that star, and that star and that star. See that little square? That's the house. Now it's a very high-peaked house. Must be in an area of huge snowfall. So that peak is the top of the roof. So in the attic, off to the left a little bit, is G318. But here's the thing. Let me get real close to the camera. See how good the focal length is on this webcam. Even when you get all the way up, all you can see is just a pinpoint fleck. Okay, now let's go back to the, now this is no longer a map. This is the real-time view that our telescope is seeing. This is the real-time view. So here we are. We would have to find this house. Well, let me refine the house down here. Okay, here is the square of the house. So I'm going to zoom in. Here's the square of the house. There's the wall. There's wall number 1, wall number 2. Here's the high roof line. Huge snowfall area. Inside the attic of this house, bam, is globular cluster G318, magnitude 15.30. Take the crosshairs off again so you can see it right here. So now you've seen a globular cluster that is in another galaxy. Now, roughly how far away would this be? Because how far away is the Andromeda Galaxy, do we say? Is it, do you guys remember? Is it, I should have this memorized, shouldn't I? Somebody remind us. How far away is the Andromeda Galaxy? How do these M31 globulars compare to those in the Milky Way? They're the same. Pretty much exactly the same. Good to have you here, Mike. Tariq says RASA is a dream. It really is once you get it tuned. 2 million, Mike says. So 2 million light years away. So we're looking at a globular cluster 2 million light years away in another galaxy. This globular is revolving. This globular is revolving around the hub of the Andromeda, like a bunch of bees. Remember how our globulars go around our galaxy? Well, this globular is revolving around Andromeda. So we would have to look at each one of these little pinpoint things one at a time. And the advantage of deep sky image annotation is that we can do this much more quickly, and I might also say more reliably. We know now that that is for certain globular G318 in Andromeda, because the crosshairs don't lie. Right there. Okay, so knowing that to be true now, let's zoom through a few more of these just for the sake of understanding this. So here's G302.
DSA completed.
G302. Boy, there's a lot of latency. I was dialing away on my mouse wheel, and the actual screen was much more latent. Okay, so right here. Man, how could you even tell that that's a globular? $2.5 million. Boakes has actually figured out the kilometers for us. So that's millions, that's trillions, that's what comes next? Zillions. And then I don't know what that's called, and I don't know what that's called, but that's a lot of kilometers, folks. All right, let's go to, by the way, what I'm going to do is turn off deep sky image annotation for a second. Back way off. Go to G257.
DSA completed.
I have these keystrokes, but I have to think them through carefully. Okay, so if I click and make that live with my cursor, it's Alt-D. Then I go down here and say paste. And here's G257. So let's remember where that is. Now let's take it off while we zoom in. Zooms in so much better without deep sky image annotation on. So right there. So it must be this. Man. Now what's interesting is I think some of these were discovered as globulars in part because of the difference in redshift. So these were not all discovered as globulars by pure observation, but rather by taking the redshift readings off of them. You guys know what the redshift is, I bet, so don't let me insult you, but I'll just share it in case you're visiting the channel. Redshift with light is like Doppler effect is with sound. You know how the train comes at you? It goes, well, let's do it with a European siren. It goes, do 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 do. In other words, the siren ascends in frequency as it's coming at you, and then it descends. You get do 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 do. It goes down in frequency, and so the same thing happens with a train. It goes past us, and the frequency descends once it passes us up, because as something is going away from us, the waves are getting farther apart for sound. Well, the same thing happens to the light waves, photon packets. So the light that's going away from us, it shifts by a different amount, and that can be measured very accurately with large telescopes and photometry equipment, spectroscopy equipment, and some of these we discovered by the redshift. Not all of them were discovered by visual. Okay, so 257 we've done, right? We're going to zoom through the rest of these now real quickly. Yeah, 257 we did. So now let's visit 217.
DSA completed.
So here's 217. And then let's visit 279.
DSA completed.
Here's 279. And 244.
DSA completed.
244 is way out there in the suburbs. 231.
DSA completed.
Be there. G064
DSA completed.
is way up here. 73
DSA completed.
is almost over here in M110 in our field of view. Now probably M110 is either in front of or behind. It's probably not exactly in M110's galactic neighborhood, but it's nevertheless for us superimposed over Messier 110 here. G78
DSA completed.
all the way up here. G172
DSA completed.
right here. G72
DSA completed.
up here. G213.
DSA completed.
Here, G233.
DSA completed.
Here, G165.
DSA completed.
I didn't see 165, did you? Oh, there it is. G165, very close to the core from our field of view, but probably G165 in reality is on our side of the Andromeda Galaxy, so it has the appearance of being close to the core. Because remember, most of the time, globulars revolve around like a swarm of bees around the outside of the galaxy. They don't get into the core as much. G222.
DSA completed.
Right here. G148.
DSA completed.
Right there, G230.
DSA completed.
I didn't see that one. G230. Okay, right here. G205.
DSA completed.
Right here. G150.
DSA completed.
Out here in the suburbs, G229.
DSA completed.
I didn't see that one either. G229. So it's possible this is off field to us.
DSA completed.
Ah, there it is. Right there. G76.
DSA completed.
All the way out here. G119.
DSA completed.
Right here. G33.
DSA completed.
Didn't see that one add. G033.
DSA completed.
Okay, so that one's definitely off frame. And then G001, the first one that was discovered.
DSA completed.
Oh, didn't see that one pop in either. And then at the beginning, did we do 351? Can I sort by ID? That's so much easier. Yeah, 351 was off frame.
DSA completed.
Definitely off frame. G272. Okay. Okay, so with the exception of those two that were off frame, what this has done now is created a visual map in SharpCap, an overlay of all of these globular clusters now for individual study, and these remain in SharpCap now that they're pasted in here. So when we do these in the future, we don't have to go back and paste them again. They're going to always be with us in SharpCap. So that's kind of cool. So for each one of these, I think G001 was one of the ones that was off frame, wasn't it? We can actually go to it. So let's just for fun, let's where's the little checkbox that lets you save the annotation? Save. I'm looking for the checkbox. Settings. Ray, do you know where that is? Help me out, Ray. Catching up with you guys. Wow, Tariq has kind of maintained a collection of scopes, and Dave says when he was starting out in astronomy, he shopped by Tariq's posts. That is crazy, isn't it? Small world in astronomy. Ray, I was wondering where's the setting that lets you save with deep sky image annotation, I wonder? I can't seem to find it now. Auto save on clear close. I thought there was a setting that said, when you save this picture, save it with all those annotations that you've made. But I'm not seeing it. Dave says, Tariq has good taste in astronomy. Yes, it's Doug. Right, Tariq. Tariq's figuring out how he'll do EAA with his scopes. Well, anyway, I'm just going to save this stack. And then let's drop out of warp drive here. In other words, let's drop out of our stacking. And just for the sake of completeness, let's go look at G001 wherever it is. And in my map, I guess I'll put M31-G001 in my file saving. Okay, so you see, we didn't have to go very far, but here's a globular cluster that is so removed from Messier 31, the Andromeda Galaxy frame, that it's outside of the RASA's frame for the Andromeda Galaxy, which is totally interesting, because now you might ask, well, man, if it's not even in the same field of view as the RASA 11, which has one of the largest fields of view of any telescope, then how do you know that globular cluster G001 is traveling with the Andromeda Galaxy? And the answer is, again, redshift. You measure the redshift of the galaxy as a whole, you measure the redshift of the stars around it, and you say, okay, that galaxy is on its own trajectory. But look, here's a globular that's not traveling with the stars. It's traveling with roughly the Andromeda Galaxy, almost. So this helps us understand that this lone globular that looks like it's way out here in the middle of nowhere is in fact indeed actually a trailing element of the Andromeda Galaxy. And the same could be said for the other one that was out of frame. I think it was 272 maybe. While we're here, let's plate solve only. Let's zoom in on this particular globular. Look, it's Mickey Mouse ear globular. We'll call it the Mickey Mouse glob. So this is M001. I'm sorry, G001 and M31. And we're going to do a quick observation of it and uncheck, add to the other 28 objects. We're going to say G001 could be called the Mickey Mouse globular. Also, it trails M31 so far behind or ahead that it isn't even in the same field of view as M31 for our RASA 11.
Observation logged.
Okay, so Ray didn't know where save with annotation is either. Ah, okay, rarely use live stacking. Tariq started in 2017. We'll all have to look up your telescope reviews, Tariq. Now, Phil Harrington doesn't write a lot about all these. Here's that beginning page, object 178, globular clusters M31, and there's the diagram. And this is virtually all he does. He gives you a chart and 2 columns and a smidgen. So really just 2 columns on everything. So, but I will read a section of this text. The Andromeda Galaxy was probably one of the first galaxies you ever saw firsthand. It was in my case, Phil says. That was in 1969, and in the ensuing 40-plus years, I have grown to appreciate as far more than just the ill-defined oval blur I drew in my logbook. Back then, the thought of seeing individual objects within M31 never crossed my mind. That changed in 1984 when Arizona astronomer Brian Skiff penned an article in Deep Sky magazine. His article, simply titled All About M31, included details for viewing many of the galaxy's open and globular star clusters. Skiff noted that a total of 355 globular clusters were identified as gravitationally bound M31 in Paul Hodge's seminal work, Atlas of the Andromeda Galaxy. Imagine spending your life cataloging all these globulars in the Andromeda Galaxy. So now they've added 100. Over the next years, we've added 150 plus additional globulars. So he just gives us the brightest ones. And he says, of the globulars in the table, the brightest and largest by far is G001. It lies more than 2.5 degrees southwest of M31 central core. That proves a real blessing since it removes its delicate glow from the galaxy's bright spiral arm disk. He tells you how to find it. He says, two fainter stars stand guard on either side of the globular, one to the northwest, one to the southwest. At first glance, it's easy to mistake all three for a tight triple star, but the globular is easily identifiable as non-stellar at magnifications above 250. So that's where we would zoom in, and I don't know, it would have been a wild guess for us to think that the globular part was non-stellar, huh? Because at our level of focus right now, and with the RASA, they aren't particularly different. I mean, it's bigger, isn't it? The Mickey Mouse face is bigger than the two ears, but maybe with a tighter focus. If we would take time to focus again, those would be more pinpoint. So this is the most well-known one. And all the others are much smaller than G001, and they're superimposed somewhere on the disk. So they're much harder to see, and he says they look like faint anonymous stars. He says if you get up to 300 multiplication, maybe they start to appear non-stellar, but not much. And then he talks about a couple of them, but really, they're all tough. And then he says G272 is out of the field of view. G272. G280 is interesting because there's a soft glow there. It's an open cluster of stars, but not necessarily tied to Andromeda. Oh, it is. There's an open cluster tied to Andromeda. It listed as C410. Okay, so let's use that as our last object. Let's go to G280. Okay, so we'll save a copy of this just because it looks like Mickey Mouse. And then we'll go to G280. G280. Aha. That one is not associated with in my file. So I've got to fix that. How do I do that when it's not beside it? Okay, I'll have to fix that later. G280. In the meantime, let's just go there. G280. So that's soft glow. Tiffany says, cataloging globs would be an amazing way to spend time. Sign me up. All right. Tariq, thanks again for being here. It's really nice to meet you. Okay, so now we'll do this plate solve only again, and then we'll so we need to find 280 down here. Why are we not seeing 280? Oh, that's because we didn't paste it in yet.
DSA completed.
Okay, so there it is. So let's kind of remember where that is, and we're going to zoom in. There's too much latency to zoom in. So how will we remember? Here are 3 stars in a triangle. Okay, so we're going to take deep sky image annotation off. Zoom in right here. Oh yeah, you can already see that cluster. So there's 280. And then here's that little open cluster. So not only are there globs that are traveling with Andromeda, but there are open clusters that are traveling with it as well. And that open cluster is cataloged as C410. So I wonder if we could add C410. Oh, it's going to get mixed up with the Caldwell catalog. That's sad. Multiple IDs. Nope. So I'm going to have to add C410 manually, but we don't have the coordinates. So I'll have to look that up in Hodge's Atlas. But it'd be fun to add C410 and add that to our, for right now, let's just put it under the G280 observation. We could clearly see C410 open cluster alongside G280. The open cluster also travels with Andromeda. Fascinating. Who would have thought that tonight
Observation logged.
we would be charting objects that are integral to another galaxy? Open clusters, well, open cluster, globular clusters, and even an open cluster. It's fascinating, isn't it? Okay, Tiffany says, really nice group of objects, gorgeous. You're very kind, Tiffany, you're encouraging. I know stuff like this is a little bit technical, but I think it really does increase our skills as observers. And you guys can now tell your friends when you go to work tomorrow, last night I saw an open cluster. And your friends will say, man, Pleiades is open a cluster. We've been seeing open clusters all along. But the open cluster I saw was C410, and it's an open cluster in the Andromeda Galaxy. Have you ever seen it? And they'll say, what? Unheard of. Until tonight. So Thanks for being a part of this kind of astronomy. If you like this, I hope you'll subscribe to Emerald Hill Sky's channel on YouTube. You can also click, if you want, the like button, the thumbs up. You could also click the bell, which would do a better job notifying you of when we're going to do these live streams. You could also go to the website, which is separate from the YouTube channel, www.emeraldhillskies.com, and there you can sign up for an email newsletter. And we do both. We notify people by YouTube channel notifications and also emails. Usually, if we're at the top of our game, the night before we observe. Sometimes we do it on the fly quickly and it's a few hours, but most of the time it's the night before. You'll get those notifications. And we hope you'll join us again if you like this kind of content. We do electronically assisted astronomy exclusively. We don't even own an eyepiece. So this is all EAA, and we hope you come back. Let me see if you guys have said anything else. Boke says, I'm at work now. My workmates don't share my love of the night sky, though. Bummer. Sorry about that, folks. But we're glad you're able to sneak away for a while and take part in this. Thanks to everybody who's taken part. We've had a good number here with us, 15 right now. Tiffany says, thank you so much, but thank you, Tiffany. Thanks to everybody that's in here. Wendy, Tariq, Red Angel, Ray, in other words, Azray. Boy, we've also enjoyed visits by Bokes and Dave and Mike and Larry and a bunch of others. And if you're watching by recording, we hope you stop by. Thanks so much for being here. God bless. Good night from Emerald Hill Skies. Thanks to God for making all these cool things in the Andromeda Galaxy. We'll see you again.